And you should see my opening slide there, I think.
Yes.
Okay, excellent. Well, just want to say thank you to Bishad for inviting me here, and it's great to be presenting to you today. I did have an opportunity about a year and a half ago to present to the Alberta section, and I gave a talk there on filtration in mining, and that's available from there, the SCLE Alberta channel. So if you wanted to watch anything on that, feel free to shoot over there and you can check that out. Yeah, a bit of my background. I after high school, I did 2 years of mechanical engineering at the British Columbia Institute of Technology. While I was doing that schooling, I was working at the Chilliwack Honda motorcycle shop, and I was in service and parts there. And as a motorcycle enthusiast, that was kind of an excellent job at the time, and I had a great time, learned a lot from that experience. Um, and being part of a family business, my father founded our company, Klassen Specialty Hydraulics, in 1991. We've been the Canadian distributor for CC Jensen since '94. And just this spring, we changed our name to Klassen Advanced Filtration to better reflect our core business. Now, as anyone who grew up part of a family business knows, there's often very little separation between work and personal life, and our family was certainly no exception. Oil filtration and contamination issues was a constant topic around our dinner table. So I became immersed in it from quite a young age. Since then, we've grown from a literal mom and pop operation to now having 4 full-time and 3 part-time employees. And we're serving all major industries in Canada from coast to coast to coast. So our major markets include mining and oil sands, power generation, marine, pulp and paper, and manufacturing. So that brings us to my presentation today, varnish. And naturally, we should start by defining what is varnish. Unsurprisingly, if you talk to most of your friends, this is what they'll think of when you ask the question or start talking about varnish. And naturally, you are a group of lubrication and tribology engineers, so you know a lot about varnish already. So, of course, this is the varnish that we'll be talking about today. Um, and we've learned a lot about varnish over the last couple of decades. I'll take you on a little bit of the journey that we went on here at our operation in Canada. Um, Probably one of the first major learning experiences came in 2002, and we were working on a bale press at a pulp mill that was experiencing some issues, and we sought to try and help them with that. And using some of the kidney loop filtration systems, we started to purify it, and while we were doing that, we realized that this was more than just particulate contamination. We were dealing with some other stuff going on here. One of the tools that we used at this point was the ultracentrifuge, which you can see here, and we were just capturing things that we hadn't really seen before. So we learned a lot from this process. We filtered the oil for about 12 months, and we saw that nice bright looking clear sample there, and the mill figured, okay, we're done here, so we don't need to spend this money on filtration anymore. And they took the filter off, and 6 months later it was looking just about as bad as before we had done anything. So what was going on? So that that kind of pushed us onto this quest of learning more and more about varnish. Over the next number of years, um, we tried to learn as much as we could. We commissioned reports, we talked to experts, we conducted experiments, we used different filtration configurations, different filter media. We analyzed and interrogated whatever we could. And we did learn a lot. For one thing, we learned that a single filter cartridge could capture in excess of 15 pounds of varnish. And it wasn't trapped on the surface of the filter, but it was absorbed throughout the fibers of the filter. So it was an extremely strong bond, and that was some vital knowledge. So we kept working with it. I would say the next big revelation we had was working with a gas turbine in Fort McMurray, and we were confident that we could improve the system. Again, they were seeing some issues with varnish, and we brought a little test filter cart along, took a small sample of oil out of the turbine, and began to filter it. And we filtered it for about 30 hours, and we had a look at the sample from where we started, and we thought, wow, this is great. So we had a nice dinner that night and went to the hotel, and in the morning we thought, okay, we're going to document this, we're going to take some pictures, and realized that we had forgotten the oil sample in the truck. And this was Fort McMurray in the winter. So we went out to get this freezing sample of oil and set it on the counter, and we thought we must have made a mistake. This oil was not the same as what we had just been working with. It was cloudy, and it did not have the clarity and the crispness to what we had seen the day before. And then we started messing around with temperature and warming it up, and realized that this can have a big swing on how the samples look. So this was the same sample at the left on at 25 degrees C, and at the right at 0 degrees C. And that got our gears turning, so we started doing some more work with that. Eventually, or by the end of this particular project, we continued the accelerated test from where we thought we had finished. At this time, keeping it at a constant temperature, and again observed the clarity change to the samples. So this was a big learning experience for us. From there, we were doing some more work with it at some other sites. We came up with a prototype design using a little bit different configuration, and a few other things that we had come up with. And things were working actually pretty well. Things were heading definitely in the right direction. We were sharing this information as we were learning with the manufacturer in Denmark, their engineers there, and learned that they were also working on a specific varnish product. So we were comparing notes with what we were doing there. And in 2010 was the commercial release of what we called the varnish removal unit, or the VRU. And this was kind of utilizing all the knowledge that we gained over the previous years, and we saw some remarkable improvements. So this was a gas turbine filtration. This is the stack of used filters from our previous style of filtration, just a basic kidney loop, and running on the same system simultaneously, we had our varnish removal unit, and this is what the filter stack looked like in that. So we really knew that we had something, and we made a point of documenting that, and we got in the practice of taking inlet and outlet samples simultaneously from the system while it was running, and ran these as patches, and were able to trend and to see a remarkable improvement of single pass efficiency, of varnish removal, and then that continued over time. So this was a great product, and it has been and continues to be a great product. Now at this time though, the testing and the reporting was a little bit all over the place. There was a few labs that started doing varnish testing, a few others came online, and everyone kind of had their own way of doing things. And as such, the results didn't translate very well from one lab to another. And sometimes the numbers, they used different scales, a different maximum. Sometimes they used different things altogether. There was some that were doing RGB and giving numbers on a scale like that. Some stuck with the ultracentrifuge. They had their own proprietary naming convention and numbering. And this made it pretty confusing for users in the field, especially if they were shopping around or using different laboratories at different times. Um, and the industry realized that we need a standardized test here that we can use to properly trend and document varnish. And that's where the ASTM D7843 came into effect, and that's exactly what it was. It was a set procedure that any lab could follow to achieve consistent and repeatable results. Um, and by this time, varnish had become quite a hot field, um, with many new products on the market. And that included things like electrostatic precipitators, agglomerators, ion exchange resin beads, additives, even anti-varnishing oils. And a lot of these things are still available on the market today. Um, we did notice with the lab in Denmark had been doing their own MPC tests before the ASTM standard as well, and when the final test was released, they noticed a few subtle differences that did tend to make um, shift the scale down, so to speak. So it seemed slightly easier to achieve better results. And this was something that was it did have an effect on the varnish, and it did seem to make it easier to get good numbers from a lab report. Um, so the many of these technologies did in fact show good effectiveness as it came back from laboratories, but that didn't always tell the same story, and made us kind of wonder, is this just a trick of lowering standards to make things seem better? And ultimately, it's the systems that tell the story. And we would have customers call up with scenarios like this, where their sample report would come back as normal, but their system was anything but. So, so what's going on here? How does this happen? This is something that we do see in the field. So why would a system seem fine sometimes, but not at other times when nothing else has changed? How can new oil get varnished so quickly after an oil change? And this is where the translation it starts. What I'll the title of my presentation, Translating Varnish. So um, it, I'll try and get into a little bit of breaking it down, maybe going backwards a little bit from the high-end science and the chemistry, but now bringing it back to practicality. So to do so, we have to get to know varnish on a cultural level and in the context of its own environment. So one of these contextual attributes is its cyclic nature. The cycles can happen for various reasons, and they can happen for more than one reason at a time. So this is a graphic showing a cycle we often observe due to the cleaning effect. Um, so as a system or a strategy takes the varnish out of the oil, there is a equilibrium that is always at play. And when varnish becomes plated out in a system, and you then take it achieves an equilibrium state with the varnish that's in the oil. So when you take the varnish out of the oil, that's going to take varnish back off of the system that's been plated out and bring it back into the oil. So you do get these cyclic periods of rising and falling, and this is something that we've observed countless times um, using our varnish removal unit. We see a rapid drop, and then an increase and a wave, and the waves can continue like that for some time, depending on how bad the system is to begin with. So another cycle that we've observed before, this was a gas turbine control system, and um, they had some high numbers, and this was followed by an improvement. They thought, hey, we're doing great here, and then it resurfaced, and it was it was bad. It was clearly in the caution zone, and they needed to do something about it. So looking at a trend like this would make us question, well, what's going on here? This was with nothing changing to the system. But what we did observe is that this was a change, a cycle through seasons. So and the theory here is that in summer, the samples showed like there was a lot of varnish in the oil because it was pulling it into the oil, and in the winter, this was in a cold location in Alberta, and um, one could surmise that the surfaces of the tank or of various parts of the system that were exposed to the cooler temperatures, that they would collect the varnish, it would precipitate to those surfaces and cling to them coming out of the oil and not show up as reportable or as a serious problem on the sample reports. Come back into summer, that varnish transitions again and moves back into the oil, and suddenly it shows they've got a problem again. So these seasons really only hit it. It never went away. And users can often describe varnish in ways that the lab can't. So I'll even suggest the most applicable description is cheap varnish and expensive varnish. So cheap varnish is the varnish that's in the oil. That's the easiest place to remove it from. The expensive varnish is already stuck to the insides of your oil system, and this is going to cost something to remove, be it by filtration or flushing or opening it up and getting in there and physically cleaning it. Now, even the most expensive varnish is stuck to the places where you least want it. And that's the varnish that's going to cause operational issues and unexpected shutdowns. So once it forms, it doesn't just disappear. It may change phase, change where it's concentrated, or change its saturation point, but it never gets better without some intervention. In fact, varnish is one of its own catalysts to further varnish formation, making it a real slippery slope. So leaving varnish unmanaged in the system is a lot like receiving your credit card bill in the mail and then deciding you're going to save money by not opening it. Doesn't work like that. And varnish charges interest too. And because it takes time to build up, it also takes time to remove. So thankfully, up to a certain point, the process is reversible. The effect of temperature on precipitation became one of the keys to our varnish removal solution, and together with several other important discoveries, gave our cellulose filtration technology the ability to remove both soluble and insoluble varnish, something that mechanical filtration on its own cannot do. To put it in the simplest terms, we make our filter media the most irresistible place in the oil system for varnish to collect. And being able to see it captured in the filter media became one of ours and our customers' greatest sources of affirmation of what was happening in the system. So when the lab reports would come back good, but the filters look as bad as what you see on the screen here, we knew that we had to keep doing what we were doing because the system definitely wasn't clean yet. So apart from lab reports, how else do you know what direction you're headed? Figures and data can be useful, but I'm a strong believer in making use of empirical evidence. My intention is to give you a few practical tools that you can use to make sense of mixed varnish messages, and hopefully that'll help you figure out which way you're actually going. So I have a few practical tests that I'd like to show you here, and I'm going to try it in a bit of a live cooking style demo, and hopefully this works okay. So I'm going to switch my camera here. I can figure out how to get this full screen again. Okay, what's this? So we're just trying to change my video here. Oh, maybe I have to stop presenting first. Sorry, when I went into the speaking mode here, then it changes the screen, and I can't find where I can stop presenting.
Well, at the bottom, there is something that says stop sharing or share.
Oh, maybe it's on my other screen. Yeah, I just have the panel of the speakers now. Sorry, this is awkward. Here, my video. Can anybody,
So what I
can,
can
can,
do, I can start presenting and that will
yeah,
discontinue. Let me see if that works.
okay, sure, yeah, do that.
So
Okay,
now you're not
yep.
sharing. So go ahead and see if you can do that.
Okay, here we go. Yeah, okay, good.
So we see your camera, but I think you are not presenting. I see you in a small.
Okay, you see, yeah, do you see some bottles on your screen there?
Yeah. So I
Okay,
made you presenter again, so you can present that camera.
okay. So then I go share. Yeah, if you can see the camera on there, then that should be all we need. And as long as you can
Okay.
still hear me, so that's good.
Yes, go ahead. Yeah, go ahead.
Okay, perfect. It's gonna. Okay, so the first thing that I'll show you is um, this is what I like to call the windowsill sample trend. And what we'd like to do here, um, these are just uh, basic sample bottles. We buy them in bulk. Uh, you can find them lots of different places, and you don't need to get the ultra clean bottles that like you would use for a particle count. These work really great for varnish because you can take lots of samples and it's not going to cost you an arm and a leg each time. And what we like to do is so you take your sample and just line it up on a windowsill, and if you can put a either a piece of tape or you can see these lines um, behind the bottles, and that really helps to show the clarity. So as you're moving here from some very dark samples, we can move along and you can see those lines kind of shining through, and that really helps to see the crispness of the sample, and you can see what sort of it really highlights the varnish in the samples. And a great thing about these two is you can put them in the sun, leave them for a while. You can put them in the fridge, put them back on the windowsill, and really play around with them a lot in order to see what a various system is doing. So this is a super quick, super easy way. So in addition to being able to trend, just for the record, these aren't all the same sample or from the same system. We got a bunch of different stuff in here. Um, but in addition to being able to see where you're going, you know, maybe you take a sample each day as you're making some changes, or you take it each week. Um, but it also serves as a reminder to not forget about that system. Every time you look longingly out the window, you have to look past these samples and go, oh right, I've got a system that's heavily varnished that I need to deal with. So that's one great thing that we like to do, and just as a practice. Um, the varnish can take a while to settle out or to precipitate out of the oil, and you know, one thing we like to do is to suggest to um, to let it arrive at a condition that would simulate the worst case scenario of a typical shutdown. or an overhaul. So if a shutdown typically lasts 2 weeks in winter, then put one of these bottles in the fridge for 2 weeks and see what it looks like then, and that'll give you an indication of what your oil is going to do during that shutdown. So that's one thing you can do, and I'll just move this up here. Okay. I feel like I should have some stir fry going or something here. Um, Another thing that I like to do is um, got a little centrifuge that I purchased right here, and I found these little vials again, just very cheap. I think I bought a bag of 1,000 of them, and what we can do is uh, prepare some of these vials and put them in the centrifuge. So I've got a little setup here, just bear with me. So I'll take one of these samples, and I've got these little eyedroppers here, and I do like to shake them up beforehand to make sure that anything that's settled out on the bottom is going to be captured in the sample. We're trying to paint a bad picture here, so try and make it the worst that you can. I've also had these samples in the fridge overnight. So we'll take an eyedropper here. Fill this up. There's some graduations on this on the vial, which make it easy to get the right amount. And I use a new dropper for each sample just so I'm not contaminating that. And as you fill the vial, of course, you want them to be even because you don't want to throw off the centrifuge. So the vial goes in like that. I've only put one in here. Of course, you would use more, but you can, in this particular one, you can put up to 12 vials in here, and just, of course, make sure to keep them even as you go around. Um, and then there's we'll put the lid on here. Oops. And then we close that. And I've got it set for 15,000 RPM. The normal ultra centrifuge is 17,000. This one didn't go that high, so I just spin it a little longer, and I've got it set for 45 minutes. So we can hit the start there, and you can hear it come up to speed, and it'll sit there, and it'll time out when it's done. Now I'm not going to wait 45 minutes to have it go through that process. Instead, I ran some this morning before the presentation, and I'll just show you how those turned out. So here we've got a bank of samples, and just slide this up so you can hopefully see it a little better. Now I've got, these are 3 sets of pairs, and I had a little fun, and I put one of each pair in the fridge, and I put one of each pair in a glass of hot water for about the last 24 hours. And so these are actually identical samples, but you can see in each case, I don't know if that light is shining through enough there. In each case, the sample that was cold is the one on the right of each pair, and it actually shows more accumulation at the bottom than the warm one. So that's a fun little toy. I like that one. And the last thing that I'm going to do here is oh, sorry, I'm just seeing some questions come up. Ken asks, Rick, do you prefer the ultracentrifuge over the MPC tests? Not necessarily. I like both of them, and often when we're getting samples back from the field here, I will run both. And what I'm going to show you now is an MPC test, and I've got a vacuum pump that actually my wife worked for an eye doctor, and they retired it from their testing, and I thought, hey, I can use a vacuum pump. So I've got a vacuum pump here connected to um, this vacuum beaker, and then I've got this apparatus, and um, I'll show you kind of how I go through this process. So I'll take my sample here again. Um, and oh, here, yeah, I've got graduated beaker here. Declutter a little bit. You can tell I don't do a lot of cooking demos. So what I'll do is mix this half and half. So I'm going to pour 40 milliliters of oil into this guy. Right up to the 40 there. And then I've got petroleum ether here. So this is the reduction that's used for the MPC test. And I'm going to bring that up right up to 80. So that's going to be a 50-50 mixture. So there we go. Then I'll put the stopper in. And put the left leg in and the left leg out and shake it all about. Hopefully this isn't going to be like the blender test where the top flies off and you get juice all over the ceiling, but I actually did get some on me because it's a demo and that's how that works. We need to stir that up a little bit more. Okay, yeah, you can see I've gotten some on my hands. Good job. So now I'll prepare the patch. And these are 0.45 micron millipore patch. And I lost a bit of grip with oil on my hands. And they do have these little protective papers on here, so gotta kind of fish that off. So here's our filter patch. Take the paper off this side. This is always more difficult when people are watching. Okay, there we go. So now this guy, we'll open it up here. There is a little screen support on top there. Line that back up. I put together. So now I'm going to turn my vacuum pump on. Hopefully it's not too noisy for you guys there. There we go. Give this one last little shake up here. And then in we go. Want to make sure we get all the goodness that may have been captured in there. So let this just work away here. Oops. So it is a very fine membrane. So depending on what kind of oil you're working with, it certainly can take a little while to suck it all through. Oh, just reading Peter's question here with respect to varnish coming out of solution. What is the lowest temperature at which no more varnish comes out of the oil? That's a great question. I don't typically, I guess I can say I haven't tried more than a freezer. So that's roughly minus 12. But yeah, that is a great question, Peter. Sorry, I don't I don't have the answer to that.
Yeah, no worries. I was just curious, to find out what you've seen.
Yeah, yeah. That's a worthwhile considering that.
So at minus 12, it still takes varnish, or still varnish comes out of solution as compared to, for instance, minus 10.
Sorry, I was just listening to another comment there. Uh, can you say that again, Peter? Sorry.
Well, so what you've seen at minus 12 and you tried that. So
Yeah.
it's still varnish comes out of solution as compared to, for instance, when you keep the sample at minus 10.
Y- I would I would say so. Again, I can't say that I've tested that closely at precise temperatures.
Right.
That'd be a interesting experiment actually to even to do a time lapse of the precipitation over time at various temperatures.
Yeah.
Sorry, I think I may have chosen a oil that was higher viscosity than I was anticipating.
Rick, sorry to
Yeah, no.
interrupt, but how low do you recommend to go on the varnish removal units, temperature-wise?
Temperature-wise, um, about 5 Celsius is about our lower limit that we'd run to.
All right, thanks.
Hmm. Sorry, this wasn't supposed to take this long. I had 7 to choose from, and I chose the worst one, probably. I think maybe what I'll do is just pour it out of the top here. I think you get the idea anyway. And then we'll see what we've got. Okay. Then once the oil has gone down, then often I'll just use the petroleum ether again to rinse the canister and let that be drawn through the pore. I think I chose a sample that had been contaminated with some with a lot of solid particles. So that's ironic. This seems to be really plugged up, but that's okay. It's almost through now.
Rick,
Yes.
it's Peter. You know, while we're waiting for that, I have another question
Yeah, sure.
about MPC. Some labs they weigh the patch. Uh,
Oh,
you know, so and I've never been able to find out what the purpose of that is. Do you know?
uh, I think I mean most of that stuff. My opinion is if you get into the habit of doing something and you do it consistently and you can use it for trends. I mean, for example, like we've had patches that will cling to a magnet, and so clearly there's ferrous debris um, captured on it, and even at that 0.45 micron level. So that can be pretty interesting. So you may get an idea of the kind of mass that's been captured by the patch. Um, I'm not sure, as far as quantifying it, what the benefits um, would be of that, but it's just one more thing that you may learn something really important through that, and it's again just kind of using those senses um, to gather what you're what you're working with. So I would say go for it, and you may, especially if you take it the same each time and you suddenly see differences to the mass of the patch, then that would that would prompt me to investigate a little bit further and see if I can find out what else might be going on. Maybe even put it under a microscope. Um, I've got a couple different kinds here. I've got um, a desk microscope that sometimes I'll put patches on. So right here, and I'll have a look at that. I also have a little USB one that I can connect to my laptop or my phone. So often I just follow your nose in a way, and you might learn something that you didn't expect.
Yeah.
So
Thank you.
here,
Thank you.
so here is yes, I've clearly taken a patch that was or a sample bottle that had something unusual with it. Of course, I grabbed it off the shelf downstairs, but that's made quite a beautiful pattern actually. What I'm seeing here, this is clearly particle contamination, almost like it's blocked off the patch. So I apologize. The irony that I chose a sample that wasn't varnish. If you like, I can do it again, but it was more just to show you how easy it is to do something like this in your own lab, on your own desk, in your own basement. Um, these are you can find vacuum pumps on eBay. You can find this stuff from school supply stores, and really the idea is just to take it home a bit. So bring it back to the basics uh, of being able to follow your own intuition and use some of the tools and resources that you have available rather than leaving it to a lab looking for that green check mark, that orange caution flag. So take a little bit more initiative, and it's not quite so elusive or difficult to understand as we felt like it was in the early days. We know a lot more about it, and ultimately the system is what knows the most about it. So keep tabs on your system and watch closely, and you can learn an awful lot about it that the lab isn't going to tell you. So. Um, yeah, that's kind of a rundown of what I had. Um, I think that was about the extent of it. So if there's any other questions, feel free to shout them out or type them out or whatever.
Thank you, Rick. Thank you very much. So you got all the question at the chat, right? So there is
Yes,
nothing left.
yeah, I better check here because I wasn't always watching. So here's the chat. Yeah, I don't see anything else here unless I'm not looking at the right spot. But if anybody had something I didn't answer, please pipe up and I'll see, yeah, see what I can do. But I don't see any others here.
There's a question from Mr. Todd Heindelsman.
Oh, okay. Ah, there we go. Okay. Yes, if you have to precipitate minus 10, would stay in that form that you brought the sample up to room temperature for testing. No, it will change, and we will see it change in the sample bottle. So for example, if you cool it and precipitate it, and then heat it back up, it will go back into solution. Yeah, sorry, I have missed a few here. So that is it is transient up there. I always like to do my tests when it's cold. I know the ASTM says to let it settle at room temperature, but I prefer to leave them in the fridge until just before I test them. Again, I'd rather know the worst case of what's going on in there. So I know it's not translatable to a a test from a lab, but as for the seat of the pants kind of a test, I do prefer keeping it cold before measuring. Okay, yeah, there's a comment. We always weighed before and after because we were also doing gravimetric analysis at the same time. So that's, yeah, that makes sense. That's a great point. And Ken had a few questions here that I missed. So what was better about the Danish MPC test? Well, that was the heating is the part that was the difference there. So the ASTM is to bring it to 60 degrees C for 24 hours and then let it cool to room temperature at for 72 hours. And in the lab in Denmark, they were not doing the heating. And again, it seems that some varnish is very affected by time, and so that 72 hours at rest seems to not always be enough time for it to precipitate back out. So that was one of the differences that they found in comparing the two methods. Yeah, and there Ken says the time dependency is sometimes forgotten. Absolutely. An example is wax and oil and the need to cold soak for days when doing a cloud point or pour point test. Yeah, absolutely. So time really is a big deal with varnish as well, and that's why I suggested if you're checking a system to let it sit or let it precipitate on the shelf for as long as your system outage might be, because if you're taking your turbine apart for maintenance, leaving the oil in the tank, you don't want it to all precipitate to the inside surfaces of the system while you're doing that service. So it's a good way to check it in beforehand. What is your experience with more transparent varnishes? Yeah, sometimes I'll fiddle around with my petroleum ether mixture. And again, as long as you find something that seems to work, if it's I was doing 50 to 50 here, or 50-50. You know, maybe try 60-40, even 20-80, and see if you can induce a darker patch, so to speak. Then as far as trending, just make sure you do it the same the next time, and see if, you know, follow it along that way. Is there a difference between, or a difference FTIR or whatever test between varnish and oil and varnish plated out? Okay, so like the chemical difference between soluble and insoluble varnish, or I guess, yeah. So the yeah, chemically, I couldn't speak to that myself. I don't know enough about it, but I do understand that that when it gets to that hard, you know, lacquered state, that is a different problem that you're dealing with, and once it gets to that state, there's no going back. It needs to be physically removed from the system, or from that surface. I'd have to you know, talk with our lab to learn a little bit more about the chemical, or the FTIR analysis of that in that various states.
Okay, any other questions that you have there, Rick? I think you answered all of them, right?
I think I got them.
Okay, so any other questions that you want to ask Rick, or type it in the chat? Okay, so I don't see anything. Okay, Rick, thank you very much. On behalf of Steely Toronto section, I want to thank you for the great presentation that you did. This recording will be available in our website and our YouTube channel probably today afternoon or tomorrow morning. So you can check and you see it there. Thank you very much and have a great day.
Okay, great. Thanks,
Thank you, Rick.
thanks again for the opportunity. Hopefully it was relatively easy to follow, and
Definitely.
don't look for me on the cooking channel, I'll tell you that much.
Thank you very much. You have a good day,
Right.
okay?
Thank you.
Okay,
It was great.
Thank you. Thanks. Bye.
thanks very much, everybody.